So lesson 1.2 for Algebra 2, we are talking about transformations of functions. So the first notes I want you to take all these on your graph paper for now. Okay, so label your graph paper parent functions. Okay, go ahead and label your graph paper parent functions. Okay, what I want you to understand from the word parent is the word original. Okay, so parent functions are the original functions before they've been moved. Okay, so parent functions also can stand for the original functions. So we're going to talk about 3 different functions today. So the first one I want you to write down next to one of your graphs is y equals x. Okay, that's the first function I want you to write down. Does anyone know what that graph's going to look like? If I say y equals mx plus b. I know you've all heard that before. Okay, this graph is going to look like a line that goes through the origin. So it's going to look like a line that goes through the origin. Okay, biggest thing about parent functions is that they go through 0, 0, or they start at 0, 0. Okay, so parent functions start or go through 0, 0. Okay, so y equals x looks like a straight line through the origin. Okay, the next one, on your next graph, we're going to talk about y equals x squared. This is also a parent function. Okay, this graph is going to be called a parabola. Okay, but parent functions always start where? Where do parent functions start? 0, 0, the origin. Okay, this graph is going to look like a U shape. Okay, this U shape is called a parabola. Okay, it's in the shape of a U. Okay, and then the last parent function that I want to talk about here is y equals the absolute value of x. Okay, so now we have an absolute value function. Again, where do parent functions always start at? 0, 0. These absolute value functions are going to have a V shape. Okay, so absolute value is in the shape of a V. Okay, so this thing with parent functions, or you can think the original functions, where are they always going to start at or go through? Start at 0, 0. Okay. What does the y equals x graph look like? What's the shape of the y equals x? A line. What's the shape of y equals x squared? A U. And what is the shape of y equals absolute value of x? A V. Okay. Biggest thing is knowing which function's which and what they look like. Okay. All right, you should be looking at this graph on your notes here. Which one, the blue or the red, is the parent function? Which one's the original parent function? What'd you say? Why the blue? Goes through 0, 0, exactly. So this is our parent function. Go ahead and label that in your notes. What I write down, you write down. Okay, so it goes through 0, 0. How did, and we said the parent function for this was y equals x squared because it has that U shape. Okay. How does it move from the blue to the red? What's happening? It's going down 3. Write those in words. It's going down 3. That 0, 0 is moving 1, 2, 3 to our new point here. So we're going to talk about how to write these equations from the parent function to make a new one. So how this one is written is we still have y equals. Now, did the x value move at all? Like, did we go left or right at all? No. Nope. So the x squared stays as it is. And then down 3, how do you think you would write that mathematically? Down 3. Minus 3, exactly. So our parent function went from the original, and then it moved down 3 to give us this new equation here. Okay. Let's look at the next graph. This graph here, right below that one. Which one of these, blue or green, is my parent function? Blue, because 0, 0. Yep. This time, how did our graph move? I heard it. It moved side to side, right? How much did it move? In what direction? Yep, this one moved right 3. This time, again, we're still working with y equals x squared because of that u shape. Since we're going right 3, is that the x value or is that the y value?
X.
That's the x value. Now, what's a little tricky with this is we kind of have to think opposite with what the x is. So we're going to put this in parentheses here. With right 3, what would you think mathematically? You would think plus 3, but we have to think opposite. So you would go minus 3. So x minus 3 squared. Did anything happen with the y values? No. So this is your answer for this one. Okay. So take some off to the side of your example 1 in the margins there. So if we are moving the x value, and again, x values go what direction? Left or right. Yep, left or right. So if we are moving left or right, we have to think opposite. So what I mean by that is if we are moving to the left, are we adding or subtracting? You want to say subtract, but we need to add. And if we are moving to the right, you want to say add, but we need to subtract. Exactly. So that's if we're moving the x value. Let's talk about if we're moving the y value. What direction are y values?
Right or left?
That's x values.
Up and down.
Yep, there we go. Y values are up and down. With the y values, can we think normal or think opposite? It's the same thing, right? We can think normal. So, for example, if we are moving up, what mathematical operation are we using? If we're going up, we want to add. If we are moving down, we want to subtract. Okay, so kind of use this as a little cheat sheet for you, yeah? All right, on your example 2a, you have f of x equals x squared minus 2. This time it didn't give you the graph, but from here we can figure out which parent function it is. Okay, so out of the 3 that I gave you, which parent function comes from this? Right, y equals x squared. Okay, since it has that x squared, we know it's coming from this original parent function. And you're correct, it is in the shape of that u. Okay, so what I want you to do on your graph, go ahead and draw the original parent function. Draw the original parent function, which would look like, starting where? 0, 0, and then that U shape. Go ahead and draw that. Now, what I want you to do is apply whatever rule it's telling you here. So think to yourself, what is that minus 2 telling me? How am I moving? Okay. I'm going to ask you this. Is that minus 2 talking about the y value or is it talking about the x value? It is talking about the y. How we know that is because it is not with the x. It is totally on its own. Okay, so what does minus 2 mean when we're talking about the y value? We're going down 2. So I want you to get in the habit of writing it in words. We're going down 2. Is anything else happening to our function? No, that's it. So take your origin and move down 2. And then draw your new graph. Shape stays the same because it's from the original parent function. So for your part B on that, I want you to use this equation here. If I had the absolute value of x plus 3 minus 1. Let's do plus 1. Go ahead and write that for your part B. Okay. On this one, what is your original parent function? which is the absolute value one, right? So this is your parent function. We know the graph has to look like a V. So go ahead and draw that. We know our parent function starts at 0, 0. Absolute value is a V. Now, how many things are happening here? What's happening to our graph? We have this +3 and +1. What is this +3 doing? Is it moving the x value or moving the y value? Yep, because it's inside with the x, right? With the x, do we think opposite or think normal? What'd you say? We have to think opposite for the x values. Yep, think opposite. So for +3, you would think right, but we need to go left. So we need to go left 3. Is there anything else happening? Yep, this +1 is telling us we need to go up 1. Yep, y is we think normal. Good. So now listen to that and move your vertex in that direction. So we're going to go left 3, up 1. So your new function should look like this. I'm going to give you an example. I want you to write it off to the side of your example too. I do not want you to graph it. I just want you to tell me in words what's happening. Okay, so here I'm going to give you this equation. Y equals x minus 2 squared plus 4. In words, I want you to tell me what's happening. As in left or right, how many? Up or down, how many? Go. I'm going to give you 2 here. Do that one and do this one. How many things are happening on this one? There's 2, right? We have this -2 and +4. With that -2, is that talking about the x or the y? X, because it's inside with the x. Good. With the x's, do we think opposite or think normal? Opposite. So with -2, you would normally think left, but we need to go right. Yep, so we're going right 2. This +4, what value is that dealing with? Y's, because it's on the outside. Do we think normal or think opposite? Normal. So we go up 4. And that's all I wanted. Okay. The bottom one. Even though the top one was squared and this one's absolute value, do you still think of them the same? Yes. Okay. Even though they have different parent functions, you're still thinking of them in the exact same way. Okay. So here we have 2 things happening. What is that -4 telling us? It is the x value. So you would want to think left 4, but we need to go right 4. Yep, think opposite. Right 4. What is this -5 telling us? Y value, so down 5. Okay, I think we're getting better. I want to give you a couple more examples to try. Go ahead and try y equals the absolute value of x plus 6 plus 2. And then try y equals x minus 5 squared minus 1. Go ahead and try both of those. All I want you to tell me is left or right, however many, and up and down, however many. On the top one there, how many things are happening? 2. This plus 6 is dealing with what value? X value, because it's with it. With the x values, we think normal or think opposite? Opposite. So plus 6, we would think right 6, but we need to go left 6. Okay. And then this plus 2 is dealing with what value? It's the y value. So, or do we think normal or think opposite? Normal. So positive 2 would be up 2. Okay. The bottom one there, what is this -5 telling us? Right 5. Right 5. This -1 is telling us down 1. We're going to talk about one more thing of how these graphs can change. So we've talked about how the x values change and how the y values change. Now we're going to talk about how the whole thing kind of changes. Okay, so we're going to talk about the same parent function. So our first parent function was y equals x. What did that graph look like? It was a straight line. Don't draw that. It was a straight line going through where? The origin, yep. It was this straight line. Don't draw that. Okay. What if I put a negative sign in front of there? What do you think would happen? What do you mean it would go the other way? It would go down. Yep. So we're still going to be going through the origin, okay? But it's going to be going in a negative direction now. It's going to be going down. Okay, so if I add a negative to our y equals x, it's just going to go from a positive slope to a negative slope. Still going through the origin. Okay. What did our parent function look like for y equals x squared? What shape? It was a u. So if I put this negative in front of there, what's going to happen? It's going to flip upside down. Exactly. It's going to go like this. Good. So that's our y equals negative x squared. What would happen if this one turned negative? What does this one normally look like? A V. What looks like if it turns negative? It goes upside down, still from the origin there. Oop, that was bad. So all of these just flip upside down or from a positive slope to a negative slope. Okay, with that negative in front. Okay, so I'm going to give you another example here. Okay, all I want you to do is tell me, does it flip, how it moves in the x direction, how it moves in the y direction. Okay, so here's another one. Y equals the absolute value of x plus 2 minus 5. So go ahead and use that example, and I'll give you another one, and then we'll look at a graph.
You want us to tell you what it would do?
Yep, just write what is going to happen. So is it going to flip? Is it not going to flip? How's it going to move left or right? How's it going to move up or down? All right, on this first one here, how many things are happening?
2, 3.
There is 3. What does this negative do? It flips it, right? So this would be the parent function would be a positive v. What would it do if it flipped? It would turn upside down. Good. So this one flips. What is this positive 2 telling me?
Right.
Going left.
What value are we talking about?
X.
X. Do we think normal or think opposite? Opposite. So this would have to be left 2. And then what about this minus 5?
Down 5.
Down 5. Yep. And this one here, how many things are happening? 3. Again, what does this negative do? Flip. Minus 4.
So right.
It would go right 4. Remember, think opposite. Good. Plus 2. Up 2.
So why does it change if it's absolute value and it's not absolute value?
What do you mean that?
Like plus 2, it's left, but minus 4, right?
Yep, so no matter if it's absolute value or squared, you still have to think opposite of what normally do. So with the x's, if we say plus 2, I would think all of you are thinking I need to go right 2. But we need to think opposite, so we have to go left 2. Does that make sense? Okay, so if I look at the squared one, we have minus 4. If I tell you minus 4, you would think left 4. But we need to go right 4. Yep. Oh, I forgot to put the 4 there. Okay. But x's, you're always going to think opposite. Okay? So, go ahead, do y equals, do you want an absolute value one or a squared one?
Squared.
Squared, okay. If we do x plus 3 squared minus 2. Go ahead, write what's happening in words, and I want you to graph it on your notes. What might be easier when you graph it, start where the parent function is first. If you need to draw the parent function, do that. With this problem, how many things are happening?
3.
There are 3 different things happening. I want to look at this one first. What's this negative going to do? It's going to flip. Good. So we know it's going to be flipped upside down. What is this going to do? It is going to go left 3. What about the minus 2? We're going to go down 2. I'm going to ask you this. What does the parent function to this graph look like? Yep. How do you know that the parent function looks like this? Because it is the squared. Good. So the reason I have you write it in words is because now you can just listen to what this says. Okay. So I'm going to go left 3, down 2. The flip means what? It's going to go upside down. So your graph should look something like this. Okay. Do I care about like where exactly this point falls right now? No, okay? All I care is about where your vertex is and what it looks like, whether it's going up or down, okay?